Hello students, welcome to BioWise with Aanchal. I hope the examination is going on well and little bit of topics here and there must be left in chemistry. Now I have come with a very important topic for chemistry which is called cation analysis. Depending upon what color is being produced by which metallic ion so that you can identify those ions. Okay, so let us proceed, and yes, you know what you have to do before proceeding with the video. You have to like, share and subscribe. So let us move ahead. Now, first ion that we are going to study about is the copper ion. Now, copper, you know that it is having variable valency. It is having a valency of 1 as well as it has a valency of 2. So here we are talking about the cuprous ion. Cuprous or cupric, write in the comment section. Is it cuprous or cupric? Write in the comment section. So Cu2 plus or copper 2 ion, where copper displays a valency of 2. When it reacts with sodium hydroxide or ammonium hydroxide, it gives a precipitate which is pale blue in color. You can see it in the diagram, in the picture given. And when this precipitate is added to NaOH, it is insoluble. But when you add it, the same precipitate, when it is added to excess of ammonium hydroxide, then it forms a deep inky blue solution because of the formation of a coordinate compound which is called tetraamine copper 2 hydroxide, which is soluble in water. Hence, you get a clear solution, but it is deep inky blue solution. So here, this is, you have to identify, for example, the color of the precipitate can be given and the ion can be asked in the examination. Okay, formation of this complex, though it is not there till 10th standard, but if you know, knowing extra is always better, right? So now you always remember that it excess NaOH, it is insoluble, but with excess NH4OH, it is soluble, forming a deep inky blue solution. Okay, so you can also differentiate between NaOH and NH4OH solution using any copper salt. Next one is the ferrous ion. Ferrous ion, that is Fe2 plus, where iron shows the valency of +2. When it is added to sodium hydroxide solution or ammonium hydroxide solution, it gives a dirty green precipitate. This dirty green precipitate is insoluble in excess of NaOH and as well as in excess of NH4OH. Always remember, when I say excess means you have to keep on adding and try to dissolve the PPT in it. It will not get dissolved. So the dirty green precipitate is a critical, what to say, identification for Fe2 plus ion. If you talk about ferric ion or Fe3 plus ion, where ion shows a valency of +3, NaOH and NH4OH, in both the cases, reddish brown precipitate is formed. This reddish brown precipitate is again insoluble in both NaOH and NH4OH. And by seeing the color of the precipitate, you can identify it is Fe3 plus. So whenever in a question ions are asked, do not forget to mention the charge on it. Because if I say it is iron, iron is what? It's an element, it's a metal. But if I say Fe3 plus, then I'm talking about ferric ion. So iron without a charge does not have any existence. Okay. Moving to the next, zinc ion. Now, zinc, there are three metal cations which are white in color and they give white precipitate. How will you remember the precipitate? Zinc, gelatinous. Lead, you write pencil lead, though they don't have the same chemical composition, just for a trick to remember. Chalky white. And calcium, where is calcium present? In milk. So milky white. So as we proceed, you'll understand. Zinc sulfate, when it reacts with sodium hydroxide, it forms zinc hydroxide, which is a gelatinous precipitate insoluble in Na2SO4. And when it reacts with ammonium hydroxide, it again forms zinc hydroxide and ammonium sulfate. Now, zinc hydroxide is a gelatinous precipitate formed. If you add it in excess of NaOH, it dissolves and it gives a colorless clear solution because of the formation of sodium zincate, which is soluble in water. As well as when it reacts with ammonium hydroxide, it forms a complex, that is a coordinate complex compound is formed, which is called tetraamine zinc 2 hydroxide. It is also soluble in water. So you get a clear solution in both the cases. So NH4OH or NaOH, both, if you use it in excess, it dissolves the gelatinous precipitate present. Okay. So this is how you can differentiate between the zinc and the other metals, because here both are getting dissolved completely. Moving to the next is the lead ion, or here Pb2 plus. When lead nitrate I have used, it's a soluble salt of lead. When you add this in NaOH, you have the formation of lead hydroxide. Lead is chalky white precipitate. So when lead hydroxide is formed, it appears as chalky white precipitate in the solution. And when you add excess of NaOH, you have sodium plumbite being formed, which is again soluble in water, so forming a clear solution. But when you add it to NH4OH, there is no complex formation. So the PPT remains insoluble in excess of NH4OH. Understood? I hope you understand the difference also between the zinc and the lead ion. Moving to the next is the calcium ion. Calcium, where is it present? In the milk. So the precipitate formed here is the milky white precipitate. Now, calcium sulfate, when you react with NaOH, you have the formation of calcium hydroxide as a milky white precipitate and sodium sulfate. Now, there is no PPT formed when it reacts with ammonium hydroxide. So, calcium salts are added to sodium hydroxide, milky white precipitate is formed, which is insoluble in excess of NaOH, and there is no PPT formed with NH4OH. I hope with the diagrams, it's clear and it's easily understood, right? Now that is all for the cation analysis, important for your examination. It can be considered for all the standards from 7 to 10 in ICSE and also in CBSE cation analysis. Thank you for watching. Let me know if you want anything else in the PPT or in the presentation, or if you want any other topic on which video can be made. Happy learning, children, and keep connected with BioWise with Aanchal. Thank you.